Hello again, this is ZenView Studios Lab, Eric speaking here. So today we look at some modification I did on a pair of amplifiers. Actually it's powered speakers, ALESIS powered speakers. We'll go over the small changes I did to the amplifier, which is just change the caps which are used in the power section. The first thing we show is is measurement of the THD on the non-modified amplifier, and we'll do the same with the modified amplifier afterwards to compare and see if we got any improvements. We measure also the frequency response of those speakers, namely of the 2 amps, because there are 2 amps. It's a bi-amp system with this electronic filter, and we can see directly on the frequency response curve why they sound the way they do. It's not straight, and there's too much bass. It's too bass heavy, and there's a hump around 60 Hertz. So this is something that if you want a flat response, you ought to correct. But that's another story. But anyway, this is just a little modification to try to improve a little bit THD, see if we can get better results with bigger caps. We'll do that also on another power amplifier in another video. Voila, that's it for now. So here we have the amplifier. I mean, what's inside the ALESIS? It's a bi-amplifier. You have the tweeter and the woofer, both on the dummy loads, and I'll measure the crossover frequencies and the THD of each channel to compare this non-modified version to the slightly modified version where I changed the caps, see if we improved somewhat THD or not. So that's you have to be careful. It's first of all, it's powered 220 volts on the other side, and this amp doesn't have a common ground, so you have to use probes which are not grounded. That's what I did with the spectrum analyzer. I'll show you that. But let's have a look first at the frequency response of both channels. That gives you an idea. You can see the hump here, the crossover frequency, which is about 2,500, 2K, 2.5K. That's 2K, that's about 2.5. So that tells you what the BiAmp does exactly. And this explains, this slope and everything explains why I don't like these speakers. They're too much bass heavy, and they need a correction for this to be straight and the hump to go away, this big hump here. The peak is about, let's see, that's 50 is here, so it's 60 Hertz or something like this. So that's for the frequency response. Alright, so we are now with the modified unit. Again, we'll measure one by one with one generator, both channel. Let's see, this is sorry, the right channel. The right channel we can see here alone, I mean, just to make sure the figures are okay, 77 dB, that's the highest overtone here, so that's okay. So this is in line with the measurement. Here it says 50 dB. Let's see if that's correct. 55 dB, 55 dB, so that's about right. Let's see if we reset both these. Okay, those measures seem to be okay for this. So up, we turn off this one, we turn this one on, and we set the values. Let's see, here it says 70 dB and 68. So let's see if it's correct. That's the other one. This one is the major one, so we have to put the new markers. Okay, that's the channel the high channel, and it's either this one or this one. So it's very similar, 71 dB down, so this is a little bit off, you can tell. So this now, sorry, yes, 70 dB. It's not correct exactly, because you have at least I would say 1 or 2 dB error here. So the calculation is not right. Just from looking at this, you see this is the channel. 70 dB is the highest one. It's the M2. It's this one, 70.7. So 68 is a bit low. I think it's at least 69, 69.5 or something like this. That's correct if you were to measure it, recalculate by hand. Okay, let's look. So this one, the other way around. Oops, sorry, the other way around. So this time, 73, 78 dBs. Again, this is off. That's not right. And when we have both channel on, so yes, the right channel value are incorrect. It's better. It's around 70. The minimum is 72 or something like this. So at least 1 dB better than this value. Probably closer to 73, because the 5 dB it's quite off, so this will not account so much in the THD of this, and this is totally wrong, I think. So I don't know why, but the value is not right. So the THD anyways in the 73, 72 dBs. Okay, so if we compare both, so we know, looking at the generator 2, back to this view, yeah, that it's in both cases around 73 dB for one, around 70 dB for the other. So a little improvement compared to what we had before. Now if we go back to generator 1 and 2, let's see. Okay, so generator 2, if we turn off this, we can just measure up. We have to reset that's generator 2, so that's what we were measuring, sorry. Let's see, generator 1. We have to reset the markers to get a correct approximation. This is the largest one, 77. So that's in line. Okay, for the right channel. And for the left channel, it says 51 compared to 57. So that's 55, I'm sorry, 55.8 compared to 57. So it's minus 112 here. That's also in line. So we can say those figures are about okay. That's with one channel running. And now if we run both channels, we can see nothing was changed really here. If in fact we turn it off, it's actually slightly lower. And this hasn't changed either. Okay, so we can look at the I hand. The I hand was this. Sorry, that was correct. My mistake. Now let's look at the other channel. 56 for the other channel. That's okay. And the other channel this time with the markers, the I hand markers. We see from here to this one. I think it's the highest one. We can check, but yes, no, it's about the same. 72.9, 73 M2, so 11 kilohertz, 12 kilohertz. So that's yeah, more than 70 dB off. So we can see. So these are the figures with both channels running. 73 and 70 somewhat dB THD. Okay, we have both signals on. Let's see if we can take a measure. Okay, this is the right channel, upper end. Let's see with the... Okay, that's the correct measurement, 80.6. That's about the THD for the upper channel. If we measure on the right, we have to go to this, that's the lower end, 85.8. I got 86 somewhat a little bit before. Let's see if we run. Yeah, it's about the same numbers. It's quite good though. That's it. Alright, so we see here the schematic, and this is the caps that were changed. It's C4 and C5, and they were exchanged for 470 microfarad and 1000 microfarad. That's the change we made. On the woofer, it's C34 and C31. The C4, C5, it's on the tweeter side. In the trial I made, the 1000 microfarad is better everywhere. So you can change all channel to 1000. So this is the measure. After warm-up, the numbers are a little bit better. See 86.6 dB THD. That's really what it is. But you know, 85.8, 86 is the average. And this is the same thing for the upper part. And here you get 84 dB, so a little improvement over the 80.8 dB. So this is over 80 dB, 81 dB, so that's quite good anyway. So to resume, we improved THD comparing the original unit 78 dB low channel to 86.6 dB on the modified unit, and the high frequency channel 72.7 dB compared to the 80.4. The measurements we did were based on the original unit. However, we realized the original unit was better than the modified unit originally. So we modified again, and we improved the overall response, and this is on the best unit what we got, still better than the other one. That's the final result. So to conclude, I'll say that there are variations from one unit to the other, and the best figures are with 1000 microfarad.